Hi, I'm William reporting for the Fun Robotics Network. I'm here at the Australian Nationals with Team 14579, Find Theta. They have an incredibly small robot that can do both samples and specimens. Learn about their different software protections, all on Behind the Bot. So, when approaching the season, what was your initial design philosophy for it?
We wanted a small robot which was efficient and fast and could do not all the tasks, but the ones which it could do, we wanted to do it efficiently. So on the first day, we all got together and we decided to do things like the upside down specimen, which we'll talk about later. We talked about how we were going to do our climb, which is right here, and also the materials, where we're using aluminium, where we're using carbon, and that kind of thing. So it was a very mechanically focused bot right from the start of the season.
So I see that you use an active intake. Would you like to explain and showcase how that works?
Yeah, of course. All right, so Brian, do you want to put out the intake? Yeah. So right here, we've molded these silicon rollers ourselves, and they just both spin inwards like that. If we have a sample, then we can show how that goes in. We have a button at the back of the intake, so the robot knows when the sample is in there, and we also have a color sensor to see the color. So there you go, sample goes in and it would press the button, and yeah, it goes back ready for the transfer.
So with this intake, how did you ensure that you were going to effectively get those samples inside that intake?
Yeah, so we had a sweeper on here. So one of our problems with this intake is when it drops all the way in, so when it drops all the way into the submersible, there can sometimes be samples lodged underneath it. We have this thing, we call it the sweeper, and it pushes samples out of the way from underneath the submersible. So our intake always has a spot to drop in, and that really increased our reliability in matches.
Thank you very much for showcasing that one off. So moving on to your transfer system, would you like to explain how you transfer from your intake into that transfer system?
Of course.
Yeah, sorry. Yeah. Well, what we've done is we've basically coded a system where if we hold a single button, automatically transfer it, and we've tested the reliability and it's been fairly reliable. And with this, we use weights and we use encoders to make sure that we're at the right height and to make sure that the claw has fully deposited the sample before we go down and start picking it up.
So is there any software protections that you use, especially so that there isn't any issues that arise when you're transferring and delivering?
Oh yeah, definitely. So when we're up at the top basket, when it's down, pivots down, there's no way it can go down, but if it's back up again, then it's able to go down. And we do this to make sure that we don't perform a level 4 climb. So that's one failsafe we have. Also, when scoring specimens, when the claw is up specifically like this, we can't physically make the slides go up. Otherwise, its claw would bang into that and then it would cause problems. So it forces the driver to close the claw before it goes up. And I think now Tom can talk more about the sensors.
Yes, so along with the encoders we use, we also utilize the RMU and the gyro specifically for our field-orientated movement. So rather than being robot-orientated like many teams, we're orientated to the field itself. And we found this to be far more efficient, and it didn't waste so much time with aligning the robot with separate field elements. As well as that, we utilize a limelight camera. So essentially when we're scoring buckets to align with the bucket, we scan the April tag, move some crosshairs and calculate the X distance between, and then we make motor movement to fill in the gap. And this is all automatic.
I see that you're using belted slides. Why did you choose to go with the belted slides instead of the rigging?
Yeah, so belts, we used them last season as well, and we found that we had far less breakages with the belts. We've made custom inserts for the Masumi SAR 330s and 230s, so we're using a mix on there. If we put the slides up, you can see that it's continuous, and it's just this GC2 belt which runs down and around and into the motor. This just increases the reliability so much, and we can speed up these motors as much as we want and make the slides as fast as we want, and we won't really have problems with breakages because these are super duper durable.
Something really interesting that I really love about your robot is the different cable management that you've done for your slides as well as your horizontal slides. Could you talk us through that?
Yeah, so we've seen a lot of teams. They have like a large cable which comes out the back and stuff. But for us, what we like to do is we like to use these curly cords. It's like a telephone cable, has a bunch of cords in it, and it extends linearly with the slides. We're using it both on the vertical slide and on the extendo. The extendo is slightly thicker because it has more cores for more motors and sensors, whereas this is slightly more lightweight since it goes up and it's just 2 servos.
And the last question about the overall slides is, why did you choose to make it go to angle your slides up into the center of your robot, not backwards?
We wanted to geometrically make our robot score specimens, and by that I mean it pulls them up onto the bar in one swift movement. So Guan, if you want to demonstrate the specimen intake, this doesn't have a clip on it, but we can show you anyway. It'll go there and back, and this would be the bar, and then when we put the slides up, it'll clip on in just one swift movement. And to do that, we wanted the front of the robot against the submersible, and yeah, and then it would just clip onto the bar like that.
So the last question that I have for you today is, so I know that you can do a level 2 ascent. Would you be able to describe how that overall works?
Yeah, sure. So I'll pass on to Arnav since he's worked more on this.
Yeah, okay. So with the level 2, the climbs stay locked in this position here with the cable. Stay down here. There's a string attached to the servo sitting in there. This is on both sides, and they stay locked like that. Then during end game, when we want the climbs to come out, the servo will spin, right? They will pop out, and all the springs will allow it to come straight up and at the perfect height for the climb. Now this structure does not hold the weight of the robot, so it doesn't need to be strong. It's the hooks, which then detach with magnets like this, and they hook onto the bar and then climb. Yeah. Pull the robot all the way up, and yeah.
Thank you so much for sharing this awesome and incredible design. I can't wait to see how you guys have really developed, especially throughout the nationals. Thank you so much for sharing, and good luck. This has been Team 14579, Find Theta.